Next, let us talk about two properties called accuracy and precision. Okay, and we'll define accuracy as how close we are to the true value of the quantity that we are measuring. So imagine a sensor, and let's say you have a temperature sensor and you have just measured a temperature of 10 degrees Celsius using your temperature sensor. How close is that 10 degrees to the actual temperature of the object? So uh, so if you had a much better thermometer and you compare the temperature that you are measuring, that your sensor is measuring with that particular thermometer, are you getting a result that is quite close? If yes, your device is very accurate. Okay. Precision refers to the capability of a device to give the same result when the experiment is repeated again and again. Okay, so all your sensors are going to have some noise, some random variation associated with their outputs. And as we measure the same quantity over and over again with a sensor, you would see that the results vary, sometimes by large and sometimes by less amounts. And if you have a very small variation, we say that we have a precise sensor, or the precision of the sensor is very high. Otherwise, we say that the precision is very low. Okay? So, one way to understand accuracy and precision is by taking the help of an archer who is trying to shoot arrows to a target. And which archer is more famous than Robin Hood, right? So let's. Uh, so here is our Robin Hood, and he is going to hit this target from whatever distance. Okay. Now, Robin Hood is a very good archer, and so we expect that all his arrows are going to hit uh, the center without any doubts. Okay, so that's what happens, and most of his arrows are hitting very close to the bullseye. And in this case, his arrows are hitting right where they should, right near the center of the target, which means that his shooting is very accurate. Also, notice that different uh, different times when he shoots the arrow, all the arrows are very close to each other. They hit at the same place, which means that his shooting is very precise as well. Okay. Now, let's say Robin Hood shoots at a particular target and he thinks that he's got a very accurate and a precise uh, result. But what happens is actually, by some means, maybe his vision is not fine, or maybe there is some kind of an optical illusion, or maybe it's the cruel influence of the sheriff. Whatever it is, okay, the the real target is actually this one, not the previous one. So what has he got? He's shooting at this point because he thought that this was the center. So he has got all his arrows very close to each other. So it's a very precise shooting, but it's not very accurate. All the target is missed by a considerable quantity. The true value was supposed to be here, but he's missed it. So his shooting is not accurate, but it is very precise. Okay. What happens if you have a shooting pattern like this? So in this case, we can see that that the arrows are landing all over the place, and so there is no repeatability between one shot to another, and therefore it is not really precise, but it probably is accurate, because if you take the average value of this, it would probably land exactly at the center, which means it's accurate, but it's not precise. Okay, what about this? in this case, again, we see that all the arrows are all over the place. It's not precise and it's not accurate as well, because if you take the average of these shoots, the center probably lies somewhere here, and that's quite away from the true value. So it's not accurate and not precise. Okay. Um, I always confuse between accuracy and precision, and probably you do not. And if you do not, you can ignore this. But if you do, remember this acronym, PTAC. PTAC is something like blue tack, and PTAC is basically precision means together, accuracy means the center. Okay, so if you're hitting the center all the time, you're accurate. If all your measurements are very close together, then you have precision. Okay, so how do this apply to a sensor? So let's just apply this to a sensor, and let's take a look at this temperature sensor that we have looked at before. So in this temperature sensor, we're measuring the temperature of a water bath, and what we do is we measure the temperature of the water bath, look at the output, uh, and when we get an output, we use the calibration curve to figure out what the temperature of the bath is. Okay, and that gives us the temperature of the bath as measured by this sensor. Let's also say that we know the true value of the temperature bath. Okay, now let's repeat these measurements many times. Okay, and if we repeat these measurements many times, what would we get? We get something like this. So the ideal temperature is exactly at this point. And as you repeat the measurements, you get these red colored measurements. Okay, this black trace is the average of all these red measurements. So let me just repeat that. So these red crosses denote one measurement of temperature. And this black cross is the average of all the measurements that we have made, while this yellowish golden kind of cross is the ideal or the true value of temperature. Now, if we have a situation like here, what we have is that we have an average value that is very far away from the true value. So the sensor is not accurate, or it has got a very low accuracy. And the measurements, the individual measurements themselves are quite spread apart. So we have a very low precision. Okay, in this case, we have improved upon the precision because the individual measurements are closer together, right? But the average value is still very far away, and therefore we have low accuracy. In this case, you have your measurements far apart, spread apart, but the average value is very close to the true value, and therefore we have high accuracy but low precision. And in this case, we have high accuracy and high precision. Hopefully, this helps you to get a handle on what accuracy and precision is. There are a few resources that I have mentioned on Moodle which give you some insight into how we actually characterize accuracy and precision. What I have done is given you a very qualitative description of accuracy and precision, but there are means by which you can actually quantify it.